Hi guys, today we're gonna finish the chemical reactions that we can have in organic compounds. And we're moving on to number 3, which is the elimination reaction. What is the elimination reaction? I put the concept in Spanish for those who have a little bit of troubles understanding English. Elimination reaction is when we lose one or more than one radical and we form a double or a triple bond. All right, and in here, in this reaction, we have a very important rule. Remember that in addition reaction, we had a rule that was called Markovnikov. And in elimination reaction, we have one that's called Zaitsev. Well, I don't know if you actually say it that way. And this means that we're gonna put the double or triple bond in the carbon that has the least number of hydrogens. All right, the double or triple bond goes in the carbon that has the least number of hydrogen. So we're going to start with example number 1, and example number 1 is easy. When we make an elimination reaction, we're always going to form a gas, an acid, water, etc. All right? So we're going to make the first example. So here, remember this means that we have a carbon and we have hydrogen here, and we have fluorine right here. This is bonded to carbon, hydrogen, and hydrogen. Since I'm going to put a double bond right here, because in this case we only have 2 carbons, so the bond has to be between those 2 carbons. Now I have 1, 2, 3, 4. I take one off. 1, 2, 3, 4. I take my fluorine off. So plus 1 hydrogen and a fluorine. So it's an ethene plus hydrofluoric acid. All right? So this is the first example that we have of elimination reaction. But let's make one that has a little bit more number of carbons so we can actually apply Zaitsev rules. Alright, let's try this one. Let's try CH3, CH2, CH3. 1, 2, 3, 4. Alright, we're going to make this reaction right here. So again, we're going to put it on a different way so we can see all of the hydrogens. We're going to take all the hydrogens out. We're going to see it then. Because this is going to make my reaction easier for me. OH and CH3. Sorry, my bad. Alright, so Zaitsev's rule says that I'm going to put my double bond between the carbons that have the least number of hydrogens. In this case, I have my radical right here. So this carbon is included. So my bond can either go here or can either go here. But what does my rule tell me? That I'm going to use the carbon that has the least number of hydrogens. Meaning that in here I have 3, and in this one I have 2. So my chemical bond, my double bond, is going to go between these 2 carbons. Am I making it clear? So when we put these 2 bonds here, we actually put a double bond here. We're going to eliminate this one and we're going to eliminate this one. Alright? So this go out of the reaction, meaning that we're going to have carbon, carbon, 1, 2, 3, hydrogen, and since I took out a hydrogen and a hydroxide, this together, it's gonna form me water. All right, remember that when we make an elimination, we're always gonna form something. It's not like you're gonna have 2 elements just floating in the air. You're always gonna form an acid, water, a gas, because in some chemical reactions you're just going to have to eliminate hydrogen, so you're going to make hydrogen gas with this H2. You're not going to leave them there floating. Alright, let's make a different example. I hope this was clear. Again, we put the double bond in here because these carbons have the least number of hydrogens. And since we put a double bond, we count 1, 2, 3, 4, so this one disappears, all right? 1, 2, 3, 4, and this one disappears. So that's the reason why, okay? All right, so let's picture this one, CH3, CH3. All right, exactly the same way as last time. If you're able to count the hydrogens this way, which is also an easy way, you can leave it here. But if you want to be sure, you can put it in the other way, all right, in the complete formula. So we're gonna have here carbon 1, 2, 3, carbon 1, 2, sorry, 1, 2, 3, 1, 2. All right, I'm not putting the hydrogens in this case because sometimes that takes too much. Well, I put them in the last one. I'm gonna put them in the last one. This one doesn't have any hydrogen. This one has 2, and this one has 3. All right, so in this case, I'm gonna work, this is important, but this is outside because what I wanna eliminate or what I wanna take out is the chlorine. So I know this carbon is included because it's bonded to the chlorine. So I can make my bond with 3 carbons. It can either be with this one, or this one. This carbon has 3 hydrogens, this one has 3 hydrogens, and this one has 2 hydrogens. And of course, I'm gonna choose the carbon that has the least number of hydrogens because that is Chef's rule. So I'm gonna choose this carbon. When I choose this carbon, I have 1, 2, 3, 4. I eliminate this one. All right, here I have 1, 2, 3, 4, and I eliminate chlorine. So then I have a hydrogen floating in a chlorine, all right? Hydrogen has a charge of positive, chlorine has a charge of negative. So plus HCl, which is hydrochloric acid. All right, that's hydrochloric acid. So remember something that you need to have in mind is when we make these reactions, we form acids or water. All right, it's very important for you to form an acid or to form H2O or hydrogen gas, all right, or hydrogen gas. Sorry, my bad, I forgot. We're gonna make one example of hydrogen gas. Because if you're not forming anything, probably you have a mistake in your reaction. Okay, I'm gonna make one more example and then that would be it. I'm gonna make a tiny video making an example in Spanish of the 3 types of reactions. All right, let's make one with hydrogens. Only with hydrogens, let's see. All right, in this case, we can have, we're gonna make an elimination reaction also. All right, it's an elimination reaction. But in this case, we have 1 carbon. This is the carbon that has the least number of hydrogens, so I'm gonna grab this carbon, right? And it's bonded to that hydrogen, so that hydrogen's gonna disappear. And we have one that has 2 hydrogens here, and the other one that has 2 hydrogens here. So in this case, we can either put the double bond on this side or on that side, all right? So we're gonna have hydrogen 1, 2, 3, 1, 2, 1, CH 1, 2, 3, 1, 2, 1, 2, 3. All right, so this is what I have right now, right? So this carbon, I know I'm gonna put the double bond either here or here. And in this case, it doesn't matter because they both have the same number of hydrogens. So let's say I wanna put it here. All right, I put it here, so I have 1, 2, 3, 4. I eliminate 1 hydrogen. 1, 2, 3, 4. I eliminate one hydrogen. So one hydrogen goes out of here and one hydrogen goes out of here, and they're gonna form hydrogen gas. Okay? So that's an example with the formation of hydrogen gas. Okay? And well, I'm gonna make one more example because I was forgetting from making from a double bond to a triple bond, so I'm gonna make one more. Let me just come up with it. Alright, when we have a double bond, it's a little bit easier because we already know where we're gonna put the triple bond. So let's figure this is hydrogen and let's put here an iodide. We haven't made one with an iodide. The rest of them are hydrogens. Alright, so we have this compound right here. And we're gonna make an elimination reaction. Because I have a double bond, remember we're gonna form a double or a triple bond, I already know that I'm gonna put a triple bond here. Alright, and since I'm gonna put a triple bond here, I have 1, 2, 3, 4. This one no longer belongs there. 1, 2, 3, 4 no longer belongs. Alright, so we're gonna have a hydrogen that has a charge of +1 and an iodide that has a charge of -1 adding together. So we're gonna have this compound CH3, CH2, C, 1, 2, 3, C, CH3. Alright, plus hydroiodic acid. Okay? 1, 2, 3, 4, 5. So this would be a 2. I'm gonna put the name here so that you still remember naming. This would be a 2. Pent, because it has 5. Ion, because it has a triple bond. Plus hydroiodic acid. So this is the elimination reaction. I hope it's clear. And if you don't understand, well, just text me.